Good day, viewers. Today we will be looking at how to calculate the consumption of diesel in daily operation of a telecom site. And this can also go as far as to do other evaluation for other businesses other than telecommunication, because we can also use that for anywhere we use ACD diesel generator, which is ACDG. So permit me to use ACDG as alternating current diesel generator. So I will be using the short term ACDG. So here we have here we'll be looking at the size of the generator, the consumption, the percentage utilization, which is the percentage loading of the generator. Having all these data will enable us to calculate the consumption of diesel, and having to know the pump price, which is let's say assumption. It's just a mere assumption. It's just a mere assumption. The pump price to be 2,000 currency per liter. So I just want to take that as just an assumption. It's just an assumption. I just want to take that as a value for us to enable us perform the necessary calculation. So first of all, for us to go into the calculation of diesel consumption, daily consumption of diesel in a telecom site, we need to know the capacity of the site diesel generator, site ACDG. So we must know the capacity, and we can find that capacity on the nameplate of the generator. Or we can also get this information from, apart from getting the diesel, we can also get this information from the deployment list. And also we need the site, the electrical power consumption data, which is the site load of this equipment. We need to know the site load. And also we will then need to get the consumption chart of diesel generator, mainly for ACDG. Here we will be using an average data which was downloaded from the internet. So that's what we're going to use for this calculation. Here we have the consumption chart. So this is the consumption chart. This is how it looks like. This is a diesel generator consumption chart. This is how it looks like. And all these loads, they are arranged in percentage utilization. We can see 1/4 load. We can see 1/4. We can see 1/4 load, which is 1/4 of the load consumption, which is 1/4. If we express that in percentage, is 25% loading, and here is 50% loading if we express that in percentage. And here we have 75% loading, and here we have the full loading. So take, for example, we are looking at the roll where we have the 2430 kVA. So if we look at this, so what it means is that if we load this generator, we load it at 1/4, which is 25%, the consumption will be 2 liters per hour. And if we load this generator like half, which is 50% loading, 50% utilization, we have 4 liters of fuel consumption in an hour, which is 4 liters of diesel per hour. And if we also load this in 75% loading, we have 5 liters per hour. And full loading will give us 7 liters per hour. So now, having to understand this, let's look at the site load. Here, the site load. Now, these are what we have on the site. I really paid attention to the 30 kVA because on this site we have 30 kVA generator, and here we have the load, the equipment load power to be 10 kilowatts. and the efficiency of the DC power system is 0.95. And we have this generator to run for 24 hours in a day. So this is 24 hours in a day. We run it for 24 hours a day because there is no interruption in power when it comes to telecom. For smooth operation, there must be zero downtime. And downtime is what we always prevent. So now we can go ahead to see how the typography of the site. So now as it is here, we have the 30 kVA generator, which is the DG power to be 30 kVA, which is the capacity of this generator. So if we express kVA to kilowatt, we multiply the 30 kilo kVA by the power factor, and we know that real power is equal to apparent power times power factor. So the real power is what we want here. Now we say real power is equals to 30 times 0.8, and that will give us 24, and that will give us 24 kilowatts. So now that will give us 24 kilowatts. So from here to this place, we have AC supply, AC power supply. And from here to this place, we have DC power supply. So we see that right here we have this load in DC. So we must convert this DC power to AC power. And then we can now draw the conclusion of how much this generator is loaded, by what percentage this generator is loaded. So in order for us to convert this DC power to AC power calculation, if we have the data for DC, we can also transform that to AC consumption, and with the help of the efficiency formula. And we know efficiency is equal to output all over input. So with the efficiency formula, we can get the output, which is the AC consumption of that telecom equipment. So it's always a thumb rule that whenever there is conversion in our calculation, we will always use the efficiency formula. So it's a thumb rule. Efficiency formula is used whenever there is conversion process, either from one form of energy or from one voltage to another. And there's always a loss during the conversion. So we will see the loss in our calculation now. So having to know that the efficiency of the DC power system is 0.95, which is the DC power system or the rectifier system on that site that converts alternating current to direct current. The efficiency is 0.95. Now the AC consumption will be the AC consumption input power is equals to the DC power consumption output divided by the DC power system efficiency. We know the DC power consumption output, which is 10,000 watts, and the efficiency as 0.95. So the AC power consumption input power will be equal to 10,000 watts divided by 0.95. So the answer here, the AC consumption here is 10,526 watts. We can see the difference between the 10,000 which is the DC consumption, and the AC consumption. We can see there is a loss of 526 watts. We can see that, and that is lost to heat in the form of heat. So now let's see the percentage utilization of the DG. From the previous slide, we see that the AC consumption is 10,526 watts. 526 watts. That is the AC consumption of the of the equipment, which is the telecom equipment. So we see the telecom equipment consuming 10,526 watt power from the generator. And we know that the DG, which is the AC DG rating of a 30 kVA, is 24 kilowatts. So if we express that in percentage, we'll have 10,000 divided by 25. This 10.5 we converted back to kilowatts. We converted 10,526 watts, 10,526 watt divided by 1,000 to give us 10,000, to give us 10.5 kilowatts. So 10.5 kilowatts divided by 24 kilowatts times 100 will give us 43.75 kilowatts. So this is the power consumption, the AC the DG loading percentage utilization of the AC DG. So with this now, having this value, we can move on to see from our consumption chart. So right here from our consumption chart, we'll go straight to the 30 kVA generator, and we'll see, and we'll check out the standards. So this is the 30 kVA generator. This is the 30 kVA generator, and we'll look up. If we look up to this place, we'll see that this is half, this is 1/4, which is 25% loading, and this is 0.5% loading, which is, and this is 75%, as earlier mentioned in the previous slide. So now from here, we see that we can rule out a standard, that we can use the standard of 25, since 43.75% falls within half percent loading and the 1/4% loading. So we can use the 0.5% loading as a standard for our calculation, using 4 liters of diesel consumption. And also, since we know, so with this, now we can use the standard, which is for if the gen is loaded 50%. So looking at this, looking up to the consumption charts to see the MAC rule for 30 kVA, using the standard of 50%, which is half load consumption, to do this calculation to estimate how much consumption we'll get for when we use when the generator is loaded at 43.75%. So if we look at this, if 50% load consumption of a 24 kilowatts / 30 kVA generator consumes 4 liters of diesel in an hour, how much diesel 43.75% will give us? So that will give us a value, that will give us this value here, which is this value here. It will give us this value here, this value. So it will definitely give us this value, which is the value of 3.5 liters per hour. So, but if we also use a standard of full loading, we'll see this value will also come down. But right now, so we have to take, in doing this, we have to take an average value. So if we also use the 100% load consumption of the DG, we see it uses 7 liters. Then 43.75% load consumption will give us 3.06 liters, which is less than 3.5. So there is a bit conflict. For us to clear out this conflict, we'll have to take an average of these two values. So we add it by saying 3.5 plus 3.06 divided by 2. So we have an average value. We have an average value of 3.28 liters. So with this average value of 3.28 liters per hour, we then say that the AC consumption of 10.5 kilowatts which is the AC consumption of the telecom equipment, is 3.28 liters per hour. So for now, with this now, we can also calculate the daily consumption. So calculating the daily consumption, we have 24 hours in a day. We have 24 hours in a day. And for daily consumption will be 24 hours, which is 24 times 3.28 liters per hour. So this one is per hour for an hour. So for 24 hours, we'll have this value as 78.72 liters per hour. Per day, not hours, per hour. For daily consumption, we have 78.2 liters per day. Now, it is easy for us to equate it to money. If we have a liter of diesel that costs 2,000 currency, then the cost of 78.72 liters is 78.27 times 2,000. That will amount to 157,440 currency. So that's the consumption in monetary form. So this is what we spend daily in managing this size of load in this particular site. So that's where we'll be rounding it up for today. And thank you for watching. And don't forget to subscribe, like, and subscribe this video.